Hi there, welcome to PyMath. In this video, we'll be looking at circular permutations. The formula for the number of circular permutations of n dissimilar things taken all at a time is n minus 1 factorial. So, in this formula, you got to make sure that you are watching that all are taken, and the formula states that there are n minus 1 ways of arranging things if circular permutations is used. So before we get to the circular permutations and see how this formula is arrived so that we can use them in solving problems associated with circular permutation, let's revise the linear permutation. In linear permutation arrangements, let's say there are n things that we got to arrange, then we can arrange them in n factorial ways if all of them are taken. So let's say, for example, we are talking about three alphabets A, B, and C. Because it's permutation, the order matters, and all of them are taken in this case before we get to the circular arrangement, because this n minus 1 factorial is a formula for circular permutation when all are taken. So let's get to the linear permutation again. So the number of ways that A, B, and C can be arranged could be 3 factorial, which would be 3 multiplied by 2 multiplied by 1 is 6 different ways of arranging A, B, and C. Let's see how we can do it. A, B, C is the first way, and I'm going to just move C to the first of the place, and then A to the second, and B to the third place. So I will have C, A, B, and then my third arrangement is going to be B, C, A. This is the top 3 permutation arrangements that we got. And then I'm just going to swap the B and C and then write down my fourth arrangement, which will be A, C, B. And I'll be moving B to the front, A to second, and C to the third spot, so that I get B, A, C. And again, I'm going to move C to the front and B to the second and A to the third spot, so that I'll be ending up with C, B, A. This is my other 3 arrangement for linear permutation arrangement. So I will have total of 6 linear arrangement with respect to linear permutation arrangements. So let's look at the circular permutation. In circular permutation, we'll be putting A, B, and C in a circular table with chairs arranged. So I'm going to write down my first arrangement, A, B, and C, and then my second arrangement, C, A, and B. My third arrangement as B, C, and A. If you look at them, the A, B, and C are arranged in a clockwise direction, and with respect to all of them, for A, for example, his right hand side is always C, left hand side is B. So as here, his left hand side is B, right hand side is C. So as here, his left hand side is B, right hand side is C. So nothing has changed for A. And so as for C and B also, his left hand side and right hand side wouldn't have changed. So all these 3 circular permutation arrangement is actually the same. So this is considered as only one circular permutation arrangement. But this one circular permutation arrangement led to 3 linear arrangement. This is one circular led to 3 linear because it's multiplied by 3, which is the n. So let's get to these 3 other linear permutation arrangements and see how we can see them and see whether they are actually the same when it comes to circular arrangements. So again, a circular table with 3 chairs, and I'm going to have A, C, B, B, A, C, C, B, A. So in this one, the A, B, C is actually arranged in a counterclockwise or anti-clockwise direction. And with respect to A, his right hand side is always B, left hand side is C. Here, again, right hand side is B, left hand side is C. Right hand side is B, left hand side is C. So if you look at all 3 of this is actually our second circular permutation arrangement. This 3 is actually only one arrangement, one circular arrangement, which led to 3 linear arrangement. So again, the second set, which is actually one circular arrangement, led to 3 linear arrangements. But among these 2, they are not the same. Because in this one, clockwise, this one is anti-clockwise. Here for A, B is always on his left hand side. Here B is always on his right hand side. And C is always on his right hand side here. Here C is always on his left hand side. So these 2 are not the same, but the first side is essentially the same arrangement because it's in circular fashion, and this set of these 3 is actually only one single arrangement. That's why we call it as only one, which is our second one actually, because the first one is already here. This is our second circular permutation arrangement. So what I essentially wanted to state is this is the key here, circular permutation can give rise to n linear permutation. So it means, let's say n is our circular permutation. This can lead to n number of arrangements, which will be the total number of linear arrangements, because here you have 2 circular arrangements that led to 2 multiplied by 3, 6 linear arrangements. Because these 3 are essentially the same, Here, if you look at these 3, they are actually the same when it comes to circular permutation, but in linear they are different. Here again, these 3 are different in linear, but the same in circular. So that's why we arrived at this step, where the number of circular permutation multiplied by number of things will give you the linear permutation possibilities. So the formula for circular permutation equal to n factorial divided by n equal to n into n minus 1 factorial divided by n equal to n minus 1 factorial. So that's where this formula is coming from. So hope you appreciate this understanding, and let's make sure we use this formula in the circular permutation problems, and make sure that you understand that each circular permutation arrangement can lead to 3 linear or n number of linear permutation arrangements. So that's a fundamental concept here, and the formula to remember is for circular permutation of n dissimilar things taken all at a time is n minus 1 factorial. Thank you for watching.